Let's get started with Unit 6. So this is a new unit, kind of actually pulled together some stuff. But again, we're doing generative AI, particularly with images and videos. Uh, we remember last week we talked about convolutional neural networks, and again, the project for this week and last week, this 5.6 project, is to use convolutional neural networks to either detect pneumonia in X-rays or identify whales by their tails. And this is what convolutional neural networks were originally created and used for, was these categorization problems where you have a bunch of images and they're in categories. So like these are X-rays of patients with pneumonia, and these are X-rays of patients without pneumonia. Can you determine this? Or this is um, a whale. This is this whale. This is the cat. This is the dog. This whatever sort of stuff. And we look at an image and we classify it, and we use what we call supervised learning, which is what we've been using a lot here in this class, where we have training data that and categories or you know assigned values we want for each one. But now we're going to get into more creative stuff where we're going to look at, can you just create an image here? We're going to start looking at, like, can you just create a random image? And then we're going to try to feed in a prompt, some text in here saying, I want an image that does this or that for this. And we're going to look in this. So this is all relatively new. Again, the CNNs are probably 10 years old here, where a lot of this image generation is relatively new for this. So we're going to look at that. So again, I've kind of repackaged this unit, bringing in some older stuff and some newer stuff. And one thing we get into with this new generative AI is that it's a little harder to get under the hood at all of these things. So some of the newest AI and video generation stuff, we're not going to be able to look under the hood as much as I would like there. But you will still do a couple things. So like the Explore activity this week talks about some of these text image generations techniques. And again, I'm linking to two different MIT videos, which again, I find very helpful. I'll just warn you is that these MIT videos get a little bit more mathy, a little more stats stuff and things like that in them. They do a little more deep dive into the stats there. So again, I'm not saying that's bad, but again, if you don't have a math background, you can still watch them. You might miss some of those, or lose some understanding there. But again, a lot of you have had a stats class, so that know what a normal distribution is, and then this will make sense. So again, those are the two MIT ones. Google has a little course on generative adversary networks, GANs. We'll talk about these, and these are a little out of date, but again, Google still has this course up, and it's still somewhat pertinent. Hugging Face. I don't think have we mentioned Hugging Face? Do you know who Hugging Face is yet? So now we're getting into more advanced stuff. We'll talk and use Hugging Face much more as a resource. They're a French company that started maybe 10 years ago, providing kind of open source AI models for everyone. And a lot of people now, when you create an open source model or use an open source model, you share it with Hugging Face, and Hugging Face hosts this model, or it hosts all the data and the training data and stuff like that there. So they've grown a lot. They've got a lot of support from the AI community for providing open source. They're based in France, and which is kind of nice. They follow EU rules on privacy and a lot of techniques, and EU has some really good legislation as far as that sort of stuff goes there. So they have some really good resources. They're kind of, in my mind, kind of similar to Kaggle. Kaggle is a nice company that provides some resources and a lot of the data sets and the challenges. Hugging Face is much more of new models on a lot of this generative AI stuff out there. So, just a little update, but Women in Machine Learning Conference from 2022 had a couple really good talks in this area. And I don't know, there is the 2024 Women in Machine Learning Symposium from TensorFlow is up there, but they've kind of moved beyond some of these lower level stuff here, working with this sort of stuff. But again, you can feel free to watch those talks too. Interesting. And again, always YouTube. There's some really nice YouTube tutorials out there on this. So I have a list of those. So again, you can explore those activities here. The discussion threads, I just really want us to have kind of fun this week and explore generative AI methods and videos and images, and talk about what your experience is, try out some new things. So again, I just want the discussion area to be a link to a resource that you think is good for generating AI stuff. Context, what do you think that, a little bit about it and your thoughts of this and its impact. Particularly interested in, stuff that are more than just here. You can make an image of based on some prompt there. So like we'll be looking today, like maybe at a resource that'll let you create an avatar of yourself talking. I mean, I'm kind of thinking at some point in the next couple of years, you can just replace me with a better looking version of me here, so that, we can just take my video and slap, make me look better here, and have the voice, have the whole talk, mimic my make my gestures, that sort of stuff, but just change this sort of thing. So again, this whole idea of a spokesperson or a thing like that, there are places that are starting to do that. There are I listen to a whole podcast that's all AI generated now from Perplexity every week, but I'm pretty sure there are whole videos and have been for about a year now on YouTube or Instagram or TikTok that are all AI generated, although I don't think they often say they are. So I'm interested to know if you think there are videos out there, particularly like news summaries and stuff like that. I think those are AI generated now a lot. But again, what kind of videos do you see out there in your social media that you think are AI generated? I mean, and again, we're moving beyond just the filters. I mean, we realize that there are filters you can slap on that clean things up. I'm talking more AI generate the whole video sort of stuff for this. So I'm interested in that. Or what other places are you seeing, AI generated images and stuff like that? I'm certainly seeing them, in some of my feeds. What's the new? I'm really, and now I start seeing these. I go, this isn't true, is it? So for some reason, I think it's on my TikTok, I'm seeing these videos of people scraping barnacles off whales and giant squids. And I'm pretty sure the videos are all fake and AI generate. I don't think again, just when I look at them right now, I just don't think they're real yet. And so I haven't had a chance to do a deep dive to see. I'll try to see if I can track one of those again, because it's always just when I'm scrolling TikTok and I'm not trying to, teach that point. So I'll try to grab one of those and post it, and we can maybe do it. But again, are there videos out there that you're seeing that you think, I think this might be AI generated there because of that? So let me know. So yeah, post that to the discussion area. So we'll be doing this learning notebook on this image generation on Thursday. I've got to update it. Again, like we were just talking, there's some stuff I have to update with these stuff. So I'm really not changing it too much. I'm just updating it somewhat there. And again, the project this week is actually stuff now. Oh, Joseph, you just mentioned, was it the whale project or which one? The X-ray project? One thing, again, we'll see throughout here is when we're saving the weights, there is an error, and I'm usually trying to correct it. Let's see. It should be this callbacks. I don't know. I'll have to look at it. But again, if you get an error with the weight when we're saving the weights, the recommendation, I'll try to check that out and see. But there, I try to correct those as we go here. So, uh, okay. So what are we going to do today? So I'm going to walk you through how we move from convolutional neural networks to generating images, from classification images to generating new images, with something called diffusion models and encoder decoder models here. So I'm going to walk through this learning resource. I might suggest while I'm doing that, one thing I'm looking at is we want to try out some image and video generators. So I'm wanting to create kind of a class list of image and video generators here. Again, we're doing some of this in discussions, but I want to kind of pull some of them in here. You can edit this list also and put some new ones here and try them out. So we can kind of try these out today, especially when I'm going through this project and talking about this. So you might want to keep that up as I'm kind of lecturing here to try things out. Okay, so I'm just going to go through the learning resource on these diffusion models and what's called UNet and that sort of stuff. So the first thing we have to do is talk about encoder-decoder networks here. I believe this first came across with language translation problems from like Google, where they were taking language like English and they were going to translate it into Spanish or French or whatever. And so what they would try to do is they take language, encode it into some internal representation, a meaningful representation here, and then take that meaningful representation and decode it in another language here, and then predict each word. So what they would say is that they'd feed in a couple words here, encode those words, send them to the decoder, and then the decoder would also see, like, if it's going to predict the third word, it'll see the first two words and then this decoded meaning space here, and it would then predict what the next word should be here. This was being done when we're doing translation originally. And again, Google's idea, and they largely succeeded in this, is to create some sort of meaning space for language so that they could take some information, a sentence or a paragraph, encode it into this meaning space, and then from that meaning space, decode it in multiple different languages there. So once we have this internal meaning space for languages, we can easily plug in encoders and decoders into this sort of stuff. So that's what Google was doing initially for language translation. Now, then people ask, can we do this for images? Can we take images and encode them? And a model called UNet became very popular or important out there, where again, remember with convolutional neural networks, we have these layers of features. And so again, we start with an input image, we'd apply filters. Here we're applying 64 filters, then we're applying 64 more filters, and then we're doing a max pooling where we shrink it down in size. And then again, we're applying 128 filters, another 128 filters, and again, we're shrinking it down in size, we're shrinking it down in size, and we're shrinking it down, and then we're finally flattening it into some sort of a feed-forward network. So our current, what we see last week is a CNN is just the first half of this. And then people are saying, well, can we take this internal representation rather than predicting categories? Can we use that to generate an image by doing basically the opposite thing back up here? So we're going to generate small images, features, larger images of other features, and then larger images of more detailed features, and finally some sort of original size image here. This is used a lot for like cancer detection or something like that in a cell where you're taking a CAT scan or some other scan, and you have the original image, and then you train the model to highlight where the regions that are cancerous or the regions that are a problem. We also use it like in driving, where you have a car to highlight parts of the region where a pedestrian is, or a moving vehicle, or a dog is. That what we call image segmentation. So we take an image, and now we don't just produce bounding boxes. We recreate that image, but modified with some things highlighted or colorized or something like that from this sort of stuff. So besides this kind of convolutional stuff, they found that having some additional connections from here, these layers, directly to these layers helped. So this layer sees some sort of internal state information, and also a copy of what was encoded in the features at this level with the input image for this. So again, we have this two-step process. We have an encoder that compresses the image into a small set of important features, gradually reducing its size till we get this kind of meaningful space. MIT will talk about this as terms of what is called a latent space, an internal or different representation of this sort of stuff here. And then we have a decoder, which will again take this meaning space or latent space and then decode it into some sort of image again for us. So we did that for a while, and again, we still use UNet, this sort of model, a lot when we're taking a convolutional neural network. We're not just kind of categorizing it, but we want it to generate an image back here. I remember a couple of years ago doing a Kaggle challenge for they're trying to find, I believe, oil in the ground, and they're doing ground penetrating radar or something like that, where they're scanning down like a mile into the ground there through these salts and stuff like that. And they were trying to identify salt pockets there. So they had these big images there. And again, then they wanted their training to try to highlight that and find regions of particular interest and highlight them in certain colors. So I believe my brother's new side scanning fish detector uses this to help detect the fish there, because again, he's got a depth finder that goes sideways somehow, and so it gets a picture. And again, I think this is actually using that for analyzing those images also. Okay, so but again, there we're generating an image largely based on another image there, where we're again just highlighting certain regions or stuff like that. But what if we want to generate new images? So the first attempt for this was called Generative Adversarial Networks, GANs. This was a cool idea. It was really fun to see. Again, there's a whole Google course on GANs that you can walk through as part of an explore activity there, where they're talking about generating images like this for this, and they talk about this whole structure of the GANs. And the idea is that, well, first you have a real simple generator, is a series of again, it's kind of like this decoder part of this, where you start with some random noise, feed it through, and generate a fake image of something there. So we're trying to create a fake image. And again, these are using convolutional neural networks and max pooling, or the opposite of max pooling, to generate this image. So that's one network. And then you train another network, which is more like a traditional convolutional neural network, but it takes two images rather than one. Two images here. And well, actually, we'll take images, and some of them are from a training set, and some of them are generated. And its job is to tell real images from fake images. So it actually, I'm sorry, it only takes one image, but it comes from two different data sources there. Its job is to tell you if it's a real or a fake image here. So For example, maybe we're trying to generate fake dollar bills. And so here's our initial generation is this. And so your discriminator is looking at this bill and saying, oh, that one's real, this one's fake, and easily tell this stuff. And so again, we feed real images in and generated images, and our discriminator tries to figure out which ones are fake and real. But eventually, through this process, our generator will get better at this. So when we train all these networks together. So if it gets us right, we'll train these both together, so it'll make the generator better at producing images here. So the generator gets a little better. So again, like here it is, it's trying to do this now. It's saying, oh, they tend to be a little greener and their faces in the middle and a dollar amount up here. So it's generate that. And then it'll learn to differentiate that, and it'll generate even a more realistic picture and a more realistic picture of this until it gets it much better. And so again, there's this constant battle between the generator generating better and better images and the discriminator learning to distinguish these fake images from the real images better and better. And together, these two things compete for each other until we get better results. I'll just warn you, GANs are, again, largely not used anymore. One of the problems was that getting them to train properly was really hard. One would tend to win over the other. The discriminator would, or the generator would just, one of them, you had to balance the training very well with these. And if you didn't balance the training properly, they just didn't learn. One of them got so much better that the other one couldn't keep up. So generative, these GANs are kind of known to be very challenging to train. So we've kind of moved away from them, but this idea of taking random noise and generating images from them is what we are actually going to take from this, is that we're taking random noise and generating an image from this. So this is the diffusion model, or what we call diffusion, and how almost all image generation works today is with this sort of diffusion sort of idea. Here, I'm going to play a little bit of this video. How's my sound volume here? Okay, I want to jump to about up ahead a ways.
Diffusion models draw inspiration from physics, specifically thermodynamics, and while they were first introduced for image generation in 2015, it took a few years for the idea to really take off. Within the last few years, though, we've seen a massive increase in the research space and industry with diffusion models. Diffusion models underpin many state-of-the-art image generation models that you may be familiar with today. Diffusion models show promise across a number of different use cases. Unconditioned diffusion models, in which models have no additional input or instruction, can be trained on images of a specific thing to generate new images of that thing, such as faces. Another example of unconditioned generation is super resolution, increasing image quality. Conditioned diffusion models give us things like text to image, generating an image from a text prompt, and image editing or customizing an image with a text prompt. Let's dive into diffusion models and talk at a high level about how they actually work. In this talk, for simplicity, let's focus on unconditioned diffusion. Now, this is a real...
So this is one of these videos that really seems kind of AI generated. Doesn't the voice sound AI generated? Or at least, I don't know if it's a real person reading AI generated text or if it's the whole thing. So what do you think is, oh, sorry, I shouldn't interrupt, but I just...
really, really interesting idea. It's quite different than any other image generation approaches. Destroy structure in a data distribution through an iterative forward diffusion process. Learn a reverse diffusion process that restores structure and data. The goal is that by training a model to the noise, that model will be able to take in pure noise, and from it, synthesize a novel image. Now, I know there's a bit of math notation on this slide, so let's break it down a bit. We start a large data set of images. Let's take a single image, shown here on the left. We start the forward diffusion process to go from x0, the initial image, to x1, the initial image, with a bit of noise. We can do this over and over again, iteratively to add.
She said that start with the image on the left, but it's really the image on the right. We start with this fully trained image here, and then we're kind of going backwards.
More and more noise to the image. This distribution we call Q, and it only depends on the previous step. We can do this over and over, iteratively adding more noise. Ideally, once we do this for a high enough T, we have reached a state of pure noise. The initial research paper implemented this with T Boris 1000. Now we want to do this in reverse. How do we go from XT noisy image to XT minus 1 slightly less noisy image? And each step of the way, we also learn this reverse diffusion process. That is, we train a machine learning model that takes in as input the noisy image and T and predicts the noise. Let's take a look at this from another angle. We can visualize the training step of this model. We have our initial image X, and we sample at time step T to create a noisy image. We train it to noisy model to predict the noise. This model is trained to minimize the difference between the predicted noise and the actual noise added to the image. In other words, this model is able to remove noise from real images.
Let's go one more, I guess.
To generate an image, we can start with pure noise and send it through our denoising model. We can then take the predicted noise and subtract it from the initial noise. If we do this iteratively, over and over, we end up with a generated image. Another way to think about this is that the model.
Okay, so what we're trying to get at is this idea of taking a clear image and we add noise to it again and again to make it noisier and noisier. And then we use, and again, we might do it on like I said, 1,000 different levels, 1,000 times to add a little bit more noise to this until we end up with an image that is all noise, basically all stuff from an image. And then we're going to train a model. And again, we know how to train a UNet model here. We're going to train a model like this, where we're going to give it an input model that is pretty noisy and have it predict a model that's a little less noisy. Because again, we started with the original image and so again, we could take, we could add just 1% of noise to it and take that image with 1% of noise and have it predict an image with no noise. Or we could, take an image that is 60% noise and have it predict an image that is only 55% noise. Just how do you get a little bit of the noise removed out of this image? How do you slowly remove noise from this? You look at a blurry image and you make it a little less blurry. Always remind, well, my dad was an eye doctor and I always have a little fascination with eye doctor, but you ever go to the eye doctor to get your eye done and they say, is this better or is this better? And with my age, they're all blurry. So I go, this is blurry and that's blurry. Well, which is less blurry? I'm going, okay, that's not, so again, is this blurry or is this blurry? And again, we're training a model to go from blurry to a little less blurry on this sort of stuff is what we're trying to do for that. Okay. So we can do that. I'm going to stick, I want to actually stick Google's Vertex AI into this list. Vertex AI is an area in Google, kind of a play area, an area where if you're building like commercial models or business models, you can use their AI models to kind of set up some stuff, but they have some really cool tools there. Okay, but I'm going to skip that for now until we generate images and stuff. Okay, let's look at this stable. So again, now we're going to look at Hugging Face resources. So Hugging Face is this French company, again, with all these models. So we're going to look at their Stable Diffusion guide here. So there are a number of models out there like that companies have made for and trained for image generation, like Dolly out there. But Stable Diffusion is one that's in the public domain, has been trained in the public domain, and is available. And you can actually download it and run it on your local PC for that. So, and that's why Hugging Face has a lot of those resources, because they have a lot of, we don't have access to the underlying models for these private systems, but these public domain ones we do. So here's, again, Stable Diffusion. It is a latent diffusion model for people. Let me see if they have a good definition of, oops, no, if they just link it in here. Here. So again, that latent diffusion model is, again, the diffusion is making things a little blurrier, and training a model to take a blurry image and make it less blurry for things here. And again, this talks about some ways you can work with these models and prompt it and set things up and generate some images there. Okay, I'm going to go back here. And I think the list resource actually. Oh, so again, we'll be looking at some of this sort of stuff where we can get a Google Colab and we can install things. And what this is kind of showing, again, is how we can start with a random noise image and have it kind of start recognizing things and generate an actual image from that random noise sort of stuff. And again, look at this sort of model. This looks very much like UNet. Again, we're downsampling. We have some meaning block down here, and we're upsampling it, and we're also sending information across here. So we're using that in our object. And again, we're trying to generate these sorts of images. So again, on Thursday, we'll play a little bit more with this sort of stuff and generating some images in a notebook for this. But let's try out a couple models and see. I'm going to run this Stable Diffusion. I don't know if I have Stable Diffusion in the guide yet. Okay. So again, Hugging Face, again, they generally don't provide all this stuff free, but they do have a couple of demo areas where you can try out different models, or these companies are let you try out different models. So this is their Stable Diffusion 3. And again, each of these things, one thing we'll see on Thursdays, we'll try out an earlier version of Stable Diffusion, see how poorly it performs compared to this. But this is Stable Diffusion 3 for this, and you can enter a prompt. So I'd like you to try to enter some prompts here. Particularly think of prompts that are somewhat specific to an area that you know about, which, again, I just don't want a horse. So my go-to prompt is college students ice fishing in Minnesota. I like that because I know I have a pretty good idea what college students ice fishing in Minnesota should look like. And it is not that typical of an image for this. So it's a challenging image for it to create. So I'm going to run something like that, generate this image and see how it runs. And again, this is taking a while because again, they're starting with a random image, a random noise, and they're slowly generating image. And we'll talk about how we feed in this text to this. So how do we do here? So yeah, call it again. We're generally pretty good at people here. And we're glad we don't have to worry about details like fingers and stuff like that. So we did okay, I think, with the people. I think we have the northern, the Minnesota background and the ice done pretty well here. But there should be holes and there should be, I mean, where is this fishing rod here? And what is this? What is this and this stuff? It looks like they have a pole going down to almost like a net and then some sort of a snowshoe down here. I don't know what that is, but it is not a fishing hole. It's not an ice fishing hole. There's no fish here. So, I mean, there are some good failures here. And again, we're not great on these faces when we look in a little bit more at these faces. But again, this is just this free model. It does okay, but again, so try again, think of some images you can try on these models there's some area that you have some special or particular knowledge of. I think that's a good way to kind of see how well these models will do here. So why don't you spend a little bit trying to generate a couple images. And again, if you go back to here and click on this video generating, we can add some items to this list here. Yeah, I'm going to let's try out Google's Vertex AI model. And again, a lot of the Google AI stuff you can't get it from, say, Scholastica, but I think, well, I can get at this. I'd be interested to see if I've had problems where because I'm in some Google stuff, can access certain things where students don't seem to be able to do that. So I can again ask like college students ice fishing in Minnesota. Generate that. And again, we can do a negative prompt. I'm going to do it without a negative prompt here. I said college. So again, it's filtering this out because it might include children, and I think it's their safety stuff is trying to prevent that. So people ice fishing. Let's just try that. Some of these are better than others. I like this where everyone's lined up here. But this is, I think, a little bit. We got people sitting on chairs, so this is a little more ice fishy like for this. So again, so try this. Try out try out some sort of a stuff and let me know, and then we'll talk a little bit. And we'll let you play with that a little bit, and then we're going to go and there's an exercise I want you to all do in a little bit down here. So we'll do this exercise in a little bit, but let's do 10 minutes playing with this. I'm going to switch that back to 5 minutes. Sorry. Let's see. Okay. Oh, I forgot to unrecord. I'm going to record this quickly again for the recorded students. So again, what we're doing is going through this little exercise here. Unit 6, click on this learning resources, diffusion models, scroll all the way down. And then in this little box here, there's this exercise. Click on that, it'll open up this stuff. But again, if you're asynchronous, you can just work on this alone. You don't have to work on it in teams. We're going to try to understand this image that comes from one of these original or this paper, high resolution image synthesis with light diffusion models. I'm going to try to have you understand that by breaking it down into parts. Each part you can do a little search either on Google or ask AI for different parts of this. Fill this in. You don't have to turn this in. Excuse me. No, it's just a learning model. Okay, I'm going to break in again just for a little bit. I'll remind you what we're trying to do here. So again, we're looking at this diffusion UNet attention notes from this model. And again, I'm trying to get to kind of understand how we could maybe work with this, how these models might work, especially how we can get maybe even language into them, that sort of stuff. And again, there's this paper here, high resolution image synthesis with latent diffusion models that I think does a pretty good job at this. But again, it's a technical paper. So it talks about how, as these graphs, talks about comparing autoencoders and GANs compared to generative, these latent diffusion models here, talks about related works, generative models and GANs, and then looks at this model that they're taking there, walks through some of the math associated with it, compares it to some other samples, models that use this sort of feature and what they're able to generate, runs a set of experiments, again, where they're trying different models out on different things here, and then they're plotting these different methods of diffusion against different models here. And here they're doing training over time and seeing how it will improve these models here. Again, this is a good paper, but again, it's just beyond the scope of this class to really analyze this sort of paper. So instead, I'm going to have you just take this one image from that paper and try to break this image apart here. We've so far talked a little bit about encoders and decoders. That's part of this process that brings things into some meaning space, or what like MIT and other technical people like to call a latent space here. So here's our latent space and what we do there and what models we use in here. So your job is to kind of understand those, understand the UNet model here and how that fits into this here. So we're using, you can kind of see a UNet model, but we have an additional thing besides UNet. We have something called attention here. Attention is the idea I want to introduce here, what's used here. It'll actually become more important when we get to language models. The main paper that set everything on fire, started the whole world of large language models. The paper's title was, you only need, attention is all you need, saying that attention was all you need in some of these models for this. So I wanted you to see a little bit of attention and begin to try to understand that you won't understand attention for a while. I still have trouble understanding how attention works here. And then last thing, see how text input is fed into this. And this might make a little bit more sense when we get to or how we send different image or different inputs into these models here. Once we get into the language model, but you can see how we can send some what do we call it, conditioning, particularly text or images into this and how it feeds into the different places here. Okay, so I'm going to let you work on this for 6 more minutes, and then we'll look at some of the ethical implications of this. So 6 more minutes. Okay, I want to turn our focus a little differently now here. So again, this is the learning activity. You don't have to submit this. I just thought you might be tired of listening to me talk so much, so I thought it'd give you a break from that. And you're thinking, that was very nice not to have you talk, Tom. Thanks for doing that. Okay, so let's look at one more thing. I want to talk a little bit about some ethical legal issues related to image generation sort of stuff here. So in here on the Unit 6, there's a link to this. And we have some basic kind of concepts. We have a couple to-do things. I think I'm going to turn the to-do things, you can try them out now, but I think I'm turning them into blending them in with the learning activity for Thursday. So some of this stuff we'll actually be doing on Thursday as far as the to-do stuff goes. So let's just talk about some of the ethical issues here. So one is just bias in these things. These image creation models are all trained with existing data. We're well aware that how you select your existing data will affect the models. So if there's any bias in your data, there could be bias in your models. Companies have actually worked hard sometimes to remove that bias with certain things with their prompts or engineering, or changing the images or weighting how many images of each type they have and things like that here. So that, it's interesting to test when you ask a model to create an image of an engineer or of like 5 engineers working together or 5 nurses working together, what is the gender breakdown of those engineers or those nurses here. There's also places where companies have tried to remove bias from their models, image generation models, and have actually caused issues where, especially with historic images, where there is historic bias in certain images, the image generation did not reflect correctly that historic bias. Question is when. So these models have to, you have to ask skills when you're generating image, do you want bias in it? When don't you? And sometimes maybe for historic reasons, to show that historically there was bias at this place or this time, you do want it there. So companies have battled with that back and forth here. I'm interested to see on Thursday, we'll try this out in some way. So we'll let you pick some bias you want to try out. And on Thursday, we'll let you try out a couple image generation methods and see what you see as far as bias goes in that. So think about what you might want to test as far as bias goes with this sort of stuff. Misinformation and deep fakes here. I don't think this is anything new in some ways. It is just, again, evolving more to what you can trust and what you can't. I mean, I think we've known that the images in magazines are all doctored and have been for the last, probably your entire life. That the cover of every magazine or every celebrity you see out there is probably, is often doctored or that sort of stuff. Or at least often that's certainly feasible. You have to question that. Certainly you grew up in the era of filters in Instagram or places like that, where we've seen all the filters you can apply, right, to change a person's look here. So that sort of stuff I think has been around, but I still and that's somewhat malicious, I guess, kind of lying to people about what people look like, creating unrealistic body images for people there. But again, part of this also gets to more uh, malicious intent as far as when you hear the term deep fake, that's usually what we're talking about is more of uh, a malicious attempt to create a fake or made up uh, often video rather than image there. But again, sometimes audio and video mixed together because again, I think a lot of people are still, although they're aware of the whole image altering stuff, they're not there yet with the video stuff out there. So I'm really interested this week to see if people, can catch some videos that are being created and posted out there that are actually fakes there. I'd be interested to see. So start watching your social media, start watching for what you think could be a fake video or a deep fake and seeing what uh we can try and look at that some more and see for this. I don't think there's great methods now to detect fake images for that. It's kind of like the fake text. When ChatGPT first came out, a lot of companies and universities was trying to put out tools that'll you feed them through, just like and see if something you wrote was generated by an AI or not there. And tell you the truth, most of those tools were not all that successful and had an error rate as high as the AI stuff goes. And AI is just improving ahead of any of those tools as far as I can tell. And again, I think the same is true images. Later on, we'll spend a little time talking about, at the end of the class, creativity. And one thing we'll talk about that is the ability of artists when they post images online to do a slight alteration to insert some like a poison underlayer in your images. Just like you can hide one image inside another, you can actually hide like a poison image inside another image so that humans don't see the difference. But when AI tries to process that pixel by pixel, AI will run into problems with it. So we'll talk about some abilities for artists to take original images and that they're going to post online and protect them some ways. So, what is your feeling about deep fakes? Are you seeing them much? Interesting. Let me know. Post in the discussion if you see some or places like that. I'm interested to see what we will see. And I'm trying to get away from some of just certainly there are high profile ones that are in the news. I'm trying to look more almost at the everyday sort of stuff that is out there too. Okay, let's talk about copyright sort of issues. So companies need lots of images to train this sort of stuff in the same way that language models need lots of words to train these models here. So some of them have kind of unscrupulously just grabbed images from all over the internet to train their models for different things. But most of images by default on the internet are copyrighted, and you can't necessarily use them to train another model here or to do something. So again, that is still somewhat up in the air on what you can and cannot do with images posted online and stuff like that. But the best models out there are trained with images that the company has the rights for to there and can then guarantee that the images that are generated that you have as a company have rights to those images also and to use those images. So there's issues with copyright, using copyrighted images to train this. There's also a question about if you create an image with the computer, can you copyright that image? And currently, the ruling is that if you use AI to generate an image, you cannot copyright that image there. So let's say you were creating a video game and you had AI create the original character for that image for that video game, and that video game turned out to be very famous. Lots of people played it, and this character was very famous. But if the character was originally created with AI, that character image is not copyrighted. And so anyone else could create and use that image, that character in some ways. Now, you can copyright subsequent things, or if you edit it, you can copyright it. But again, by default, if you just use AI to generate an image, current ruling is that you cannot copyright that image or that. I'm interested to see how this works. I know I have a couple artists that that are friends of mine, and so whenever we have dinner or something like that, it's always interesting to talk to artists. Like one, I mean, he's a painter. He makes his living selling paintings there, and and another one, she was an art teacher here, but now is retired. But again, continues to do a lot of work with painting and showing her work. And so again, they have interesting perspectives on this AI and that sort of stuff. One thing I'm interested to see is that can you use AI to generate images in the style of a famous artist or even a less famous local artist? I'm a big fan of Betsy Bowen's woodcuts. She is an artist who does a lot of images of the North Shore, and she has a particular style of these images following these woodcuts and a certain coloring technique with them. There's, generally if I'm anywhere in northern Minnesota and see one of her images, I don't even have to look at her, you can just see an image and say, oh yeah, it's a Betsy Bowen image for that. And so I'm interested to see like someone like that who's kind of famous in northern Minnesota, but not famous everywhere. Can AI generate image in her style or not? And I'm kind of thinking that it'll depend. It'll be interesting to see the safeguards put on the different image generation methods that are out there and what they can do for things. I was just doing that one with Google, and Google was not letting me generate any images of children here. Certainly, adult content or not safe for work content, a lot of the commercial image generations are not going to produce that. In fact, I asked AI to generate this initial list of ethical issues, and I guess it didn't surprise me, but I noticed that they did not put anything about adult content, nudity, that sort of idea on here, because again, most of our language models are trained to not discuss that also. So when I'm asking an AI model to identify those issues, it's probably going to avoid talking about them also. And again, this gets also to privacy. We were just talking about imitating an artist's style here. How about imitating someone's look for this? Disney's always been very protective of their looks of Mickey Mouse or Cinderella or something like that. But can you have AI generate a Mickey Mouse stuff? And again, not just a Mickey Mouse. I mean, that's but any sort of famous, infamous. And again, anyone who has their image out there, can you have AI? So if you know someone whose image is out there, who's on the internet, can you have AI generate a picture of them or some sort of model of them or something like that? So again, Thursday we'll spend some time. I'll work this. I'm deciding to work these into the assignment a little bit. So those two I think are important, but we're going to do those on Thursday as part of the learning activity. So, okay. So I'm going to wrap up today. Again, tomorrow I'll update the learning activity, and then we'll walk through that in class on Thursday. Sound good? All right.